All right, today we're going to look at section 11.2b, which is on arc length. Our objectives include finding the distance of the arc length and evaluating trig functions in radians. So first, let's go over what an arc length is in a sector and a central angle. So some of the vocab for this unit. So the arc length here, you can see in the diagram, is part of the circle. So it's like part of the circumference of the circle. Or if you think about it as a piece of pizza, it'd be the crust part. So that's the arc. The angle is going to be the inside angle here. So that's what we call the central angle. We label this distance from the center to the outside of the circle as r, because remember that's our radius. And so we have an example, we have an equation here to find arc length, and it'll be arc length, we abbreviate by the variable s, equals the radius times theta. And we do need our theta, or our central angle, to be in degrees. To radians. We need it to be in radians. So our r is our radius. Theta is going to be our central angle, and we need that to be in radians. And then we're finding for s, and that represents our arc length. So example 1, find arc length with a radius of 5 centimeters and a central angle of 45 degrees. So we have a radius of 5 and our central angle, theta. Like if we're looking at our circle, we have a central angle of 45 degrees, and I'm trying to solve for this arc length in centimeters. And I have a radius of 5. So there's just a little diagram. So right now I have a central angle of 45 degrees. In order for this to use this formula, S equals R times theta, we do have to have theta in radians. So the first thing we need to do is convert that. So remember, we convert degrees into radians by multiplying by pi over 180. So really you have 45 over 1 times pi over 180. So we can simplify 45 over 180 because 180 really is the same thing as 4 times 45. So if you think of it like that, then you can take a factor of 45 out of both, and this will reduce to pi over 4. So we get pi over 4. So 1 on top, so 1 pi over 4 on bottom. So now I can plug it into my equation. It's going to be 5 times is my radius times pi over 4 in radians. And if I want to take a whole number times a fraction, I can put the whole number over 1 and then multiply across the top. Why did I completely forget what the top of a fraction is called? Numerator. So multiply the numerator and you get 5 pi. Multiply across the denominator, you get 4. It's Friday today, and 5 pi over 4, or 5 pi over 4, I should say, it's in centimeters, so 5 pi over 4 centimeters. If I took 5 times pi, or 5 times 3.14, and divided it by 4, that would be approximately 3.9 centimeters. So I want our answers left as exact value, but just to give you an idea, that's about 3.9 centimeters. So this arc length over here is about 3.9 centimeters, given that the radius was 5 and the central angle is 45 degrees. So that's what we're finding here, is that arc length. So here's another example. We have this time a central angle of 120 degrees. So that's going to look something like this, 120 degrees. We have a radius of 12 inches, and I want to find the arc length, this section right here. So I have a radius of 12 inches and a central angle of 120 degrees. Since it was given to me in degrees, I do need to convert it to radians by multiplying it by pi over 180. So I'm going to simplify that. I'm going to first divide both 120 and 180 by 10, so take off those zeros. And then I have 12 pi over 18, and 12 over 18 are both divisible by 6. So that would be 2 pi over 3. Then I can plug it into my formula, which is arc length equals radius times the central angle. So the arc length will equal 12 times 2 pi over 3. So 12 over 1. So multiply the numerator, the top together, you get 24 pi. And 1 times 3 in the denominator is 3. Then 24 divided by 3 is 8. So this is 8 pi, and it was in inches. So our arc length is 8 pi inches, which, what does that mean? Well, 8 times pi is about 25.13 inches. So if we wanted an approximate height or an approximate length of that arc, it's about 25.13 inches, or 8 pi inches as an exact answer. I skipped the more practice converting between radians and degrees. We spent a lot of time on that in previous videos. If you still need practice with that, go ahead and look back to that. We're going to move on to evaluating the trig function, kind of using this idea. So what we're going to do is we're going to use the idea of special right triangles in this one. So here's our steps. We want to first convert radians to degrees because it's easier to think about it in degrees. Draw a picture and help us work through this. So pi over 6. I'm going to start by converting that to degrees. So pi over 6, if I want to convert to degrees, I need to multiply by 180 over pi. So the pi's cancel. So I'm just left with degrees, and then I can think of 180 as a factor of 6. It's the same thing as 6 times 30. And 6 is 6 times 1. So then 6 divided by 6 is 1. All I'm left with is 30. So this is really evaluate for the cosine of 30. I'm going to draw myself a picture. And we got 30 degrees would be going counterclockwise, 30 degrees. So I want to find this 30-degree angle, the cosine of that. So since it's 30 degrees, I can use the idea of special right triangles if I drop down a height there. And I got 30 degrees, 90 degrees, this one would be 60. And the ratios for the 30, 60, 90, remember, is across from the 30 is 1. The hypotenuse is 2 times the 30, the short leg. And the long leg is the square root of 3 times the short leg. So in the 30, 60, 90, the ratio is 1 square root of 3, 2. And I can use that ratio to find the cosine of 30 degrees then. So I want the cosine of 30, so that's this angle. So this straight across would be my opposite. The one adjacent or adjoining would be my adjacent side. And across from the 90 degrees is always the hypotenuse. If I want to find a trig function of an angle using a right triangle, we have to use our SOHCAHTOA, which reminds me that cosine is adjacent over hypotenuse. So the cosine of 30 degrees would be square root of 3 over 2. So square root of 3 over 2 is my answer then. All right. And we're going to just practice a couple more like this then. So this one is for the secant of pi over 4. So first, I'm going to convert from radians to degrees. So pi over 4, if you remember that pi over 2 equals 90, then it's just another half of that. So pi over 4 would be 45 degrees. So I like to memorize those ones. But if you don't remember that, you take the radians and multiply by 180 over pi. And then 180 is the same thing as 4 times 45, because half of 180 is 90 and half of 90 is 45. So then the 4, so factor of 4 simplifies from each. A factor of pi simplifies for each, and we're left with 45 degrees. So really I'm asking for the secant of 45 degrees. And then we need to remember the secant is a reciprocal function, and it's the reciprocal of cosine. So really I'm looking for the reciprocal of 1 over cosine of 45 degrees. So if I go back to SOHCAHTOA, cosine is adjacent over hypotenuse, and secant then will be hypotenuse over adjacent, the reciprocal of it, because cosine is opposite over adjacent. So this is 45 degrees, so I'm going to need my 45, 45, 90 triangle. So we have 45 degrees, 45, I suppose I should have maybe drawn this on my, there we go, 45 degrees, drop down, got 45 degrees up here. So the ratio for 45 degrees is 1 square root of 2. So 1 square root of 2. And then secant of 45 degrees is going to be the hypotenuse over adjacent. So it's going to be the square root of 2 over 1, or just the square root of 2. Because this would be my opposite, adjacent, hypotenuse side. But sine of pi over 5. Pi over 5, I don't know offhand what the degrees are for that, so I would have to multiply that by 180 over pi to simplify. I know that 5 goes into 180 36 times, so I can take out a factor of 5, take out the pi, and you're going to end up with 36 degrees. So really I'm asking for the sine of 36 degrees. Now, 36 degrees is not a special case. Like, it's not 30, 60. We have the ratios for 30, 60, 90 triangle, or 45, 45, 90. And so since 36 isn't a special case, I have no way of finding that degree measure without a calculator. So I'm going to type that into my calculator. Make sure that the calculator is in degree mode if you're typing it in with degrees. If you type it in with radians, your calculator could be in radians. So if you were in radian mode and typed in sine of pi over 5, you're going to get the same answer if you're in degree mode and type in sine of 36. And so if you want to give that a try, you should get 0.59 in your calculator. So 0.59. So again, you could leave it as radians and make sure it's in radian mode, or convert to radians to degrees. So 5 pi over 8 times 180 over pi. This one's a little tricky. I don't know how many times 8 goes into 180, but I do know that 4 goes into 180 4 times 45, and 8 is 4 times 2. So I'm going to start by taking out a 4 and take out the pi. So then I'm going to have 45 times 5 on the top. So, 5 times 5 is 25, 225. So I'm going to have 225 divided by 2 on the bottom. Half of 225 is 112.5. So I want the cotangent of 112.5. So I'm going to use my calculator to find that. But if you're looking on your calculator, you might not see a cotangent button because there isn't one. So you do have to remember that the cotangent is the reciprocal of tangent. So in order to put this in your calculator, you need to have degree mode, because I changed it to degrees. And then you're going to type in 1 divided by the tangent of 112.5. And then if you do that, give it a try, either in degree mode or in radian mode using this one. You will get negative 0.1414. And that's the answer for that. Let's see. These are just finding coterminal angles, so that's a review. So we've covered everything new. We started with finding arc lengths with the formula. So make sure that arc length is in radians. And then we used our special right triangle and practice just finding some functions, some values of different degrees. Okay, that's all we got today.